Hello, and welcome to another IB Math Speedrun with me, Fitz. So we're going to be continuing our exploration of histograms and ways to represent data, so let's jump right in. So when we examine a histogram, we need to focus on certain characteristics, or actually we can actually get from the analysis some characteristics of the data from which the histogram originated. So the first thing we need to look for is the center. So this will get the mean or the median or the mode of the data. Next, we need to look at the spread. So we want to look for the range, the maximum and the minimum of the data. We want to look for outliers. And the IB course defines outliers as, well, let me just quickly read this. So center, spread, outliers. And it defines outliers as a data item which is more than 1.5 times the interquartile range above the upper quartile or below the lower quartile. And finally, the shape of the graph. And so let's talk a bit about the shape of a graph. So if we have a histogram here that looks something like this, obviously all of these are being bars. I'm just simplifying it into a curve that has one clear point and other points are around evenly distributed around it. We call this unimodal. So this is a unimodal. Histogram. Now, if we have two peaks, so something like this, then this is a bimodal histogram. If we have more than two peaks, something like that, then what we have is a multimodal histogram. And finally, we have one specific case where the values are either all skewed to the left or skewed to the right. And so they're not symmetrical at all. And so we call this graph a skewed graph. So when we are comparing distributions, it's important to be clear about in your descriptions. So we want to use such as wider. So like, for example, there's a wider spread of values, a narrower spread of values. The values or data is more varied or less varied. So stuff like that. Yeah. And so that's one thing. Now, another thing to note is that when we're analyzing a histogram, it's very important to look at the, precision of the intervals. Because if we have, say, a 3-bar histogram, something that looks like this, we might say that this histogram is unimodal. But if we decrease the class interval and make it smaller, then we might end up with something like this instead, which would be a bimodal histogram. And so you can see these two have roughly the same shape, but this one expresses a very different form of data, so we want to be aware of that. Finally, we want to look at something called relative frequency. So relative frequency is the proportion of the data set belonging to the given class interval. So it's like, how much does this class interval take up of the entire data set? And yeah, it can be calculated by getting the frequency at the interval, dividing it by the total number of items. So that's all for the knowledge, and let's move on to some questions. So I'll be doing the odd ones. Actually, I'm not sure. I want to do the even ones because there's the last question I want to take a bit of a look at. So first, we have our first question. You ask everyone in your class to give you the day of the week on which they were born. So the first thing is, why would we use a bar chart? Explain why you would use a bar chart to show the result, and B, sketch the bar chart. So first, why would we use a bar chart? It's because this is like qualitative data in a sense. This is data that has really no relation to each other. Like, we have Sunday, Monday, Tuesday, Wednesday, Thursday, Friday, and these are all individual data points. We would just have individual bars for each one of them. There's no point in making the bars touch since there's no continuity between the two. And so, yeah. So finally, sketch the bar chart. We would expect something roughly even with a bit of like variation, so something like this. Sunday, Monday, Tuesday, Wednesday, Thursday, Friday, and then Saturday. So this would, we want like a roughly even distribution, but we have, a few discrepancies. Like here, we have less people born on Tuesday and Wednesday and more people born on Monday. So that's perfectly normal. That's part of the random nature of life. Technically, if we were to sketch a bar chart with a perfect prediction, we would have all equal heights. So actually, I'm going to change this prediction. So we would have all equal heights. So even though we would probably expect some variation, we don't know where it will be. So it's not fair to say that we would predict some variations in certain points when we would not know. So imagine these are all equal heights, like so. Okay, now on to the next question. And the next question is asking about this histogram. So we have this histogram. This is 150, 160, 170, 180, and 190. And we have these bars like this. And we have the frequency up here. So this ranges from 16 to 0. So this is 8. This one is 11. That is 7. And this bottom one is 3. So judging from the histogram, we need to find out the number, as this histogram shows, the amount of money given to the nearest $10 spent on food each week by the families in a neighborhood. So the first thing is we need to find out the number of families interviewed, the mean amount spent on food, and the distribution, comment on the distribution. So the number of families interviewed, well, we simply add up the frequencies for each individual group, 3, 7, 11, 16, and 8. So if we add up all of these numbers, we get 3 plus 7 plus 11 plus 16 plus 8, which is simply 45 families. So 45 families were interviewed. The number spent on food. So the thing is, to get this, we need to assume that all of the families in each class interval have that exact value of the class interval. Sorry, since this is technically discrete data, 150, 160, 170, because it's the nearest $10, and it's ranging from, this is technically 145 to 155. We just assume all of these 8 families spent $150 on food. So 8 times 150 is equal to 1,200. 16 times 160 is equal to 2,560. 11 times 170 is equal to 1,870. 7 times 180 is equal to 1,260. And finally, 3 times 190 is equal to 570. So if we add up all these values, we get the total amount spent by these 45 families on food is equal to 1870 plus 1260 plus 570. So we get that these families spent a total of $7,460 on food. If we divide this by the number of families, we get the mean, which in this case is the total population. So we use the mu. So divided by 45, this should be equal to 165 point. Normally I just give it to $166. I think that is a close enough approximation. I don't know what to say. The book says that there are 42 families, even though adding up the numbers give you 45 families, so I'm just going to have to say the book is wrong on this one. Finally, comment on the distribution. Well, it looks like a unimodal distribution that's a bit skewed to the left-hand side. But, yeah, there's not that much else to say about it. I think technically it's more skewed than unimodal, since we have this large data point over here, so it looks like this upwards trend, this downwards trend over here, with this not fitting the trend. So it's more skewed than unimodal. Okay. Finally, we have the last question, and let me draw the histogram. But we need to determine whether the histograms are systematic or skewed, unimodal, bimodal, or multimodal, and contain outliers. So the first frequency chart we have is here. It's so hard to it's so hard to draw the actual graph on. I'll just have the graph up here, honestly. This will make it easier to view. So this is the first graph. And we need to just determine if this graph is systematic or skewed, unimodal, bimodal, or multimodal, and if it contains outliers. So, is it systematic or skewed? I think it is relatively, I guess, skewed, because, there's a lot more on this side than there is here, but there's still too much here to justify it being systematic around a mode here. Is it unimodal, bimodal, or multimodal? It looks like it's bimodal. We have one peak here, and we also have one peak here. And does it contain outliers? Yes, definitely. This looks like an outlier to me. So yeah, those are the three answers. And okay, let's move on to the final graph of today, which is this very balanced graph of height. So is it systematic or skewed? It looks very systematic. It looks very symmetrical on both sides. It's clearly unimodal, and I don't believe it contains any outliers. So yeah, that was all for today. I hope you enjoyed the speedrun, and I hope to see you in the next one.